simple parabola equations, but this time using the turning point method, which isn't strictly necessary but has some advantages in the long run. At the intercept method, we just looked at the x-intercepts and placed the negative of those two in the brackets. For the turning point method, we take the y equals x squared graph and then move it left or right, then up or down, and to do that we use the general form y equals x minus the change left or right and the negative, and the change up and down in the positive. So this parabola has been moved 3 to the right and 1 down relative to y equals x squared. We take our general form, and if we just looked at the shift left or right, that would be x minus 3 squared. Even if we were using the intercept method, the dotted line would be y equals minus 3, x minus 3 squared. But our graph has been moved down 1, so we add plus minus 1, but we don't write plus minus 1, we just write minus 1. So there's our shift left or right, there's our shift up and down. Same every time. This parabola has been moved 1 to the right and 4 down, so it is x minus 1 squared for the shift left or right, minus 4 for the shift down. Here we have another one. So the shift is left, so the I is negative 1, which will be plus 1, and down will be plus minus 1. So we write that negative 1 becomes plus 1, and plus minus 1 becomes minus 1. So basically that's what we're doing every time. If we do it for a graph that turns on the x-axis, then we get the same equation, doesn't matter which method. So the turning point method is effectively taking that equation and then making a correction for the fact that it's higher or lower than on the x-axis. Negative parabolas are the same as the other method, and negative sign is added in front of the equation. So here we have a negative parabola. Now we have a minus sign in front of the brackets, but it is minus 2 plus 2 and then plus 4. So it's identical to what we were doing before, except there's a negative leading the brackets. There's some advantages for the turning point method. If the equation has no intercepts, then we can still use the turning point method. If it has intercepts but we don't know what they are, then we can still use the turning point method. So here's a couple of examples. In the green case, it turns but there are no intercepts, so we can't use the intercept method. In the red case, it has intercepts, but we don't know what they are because they're not marked as whole numbers. So the equations for these, the green, x plus 1, because it's minus 1, plus 1, and for the red is x minus 1 plus 2, but negative because it's upside down. So that allows us to do two graphs that we couldn't do with the turning point method. On the downside, we can't do it when we don't know the value of the turning point and we only have the intercepts. So in this case we would have to use the intercept method. And also there's a bit about it's confusing that the left-right correction is done in the negative, but the up-down correction is done with the positive, which sometimes confuses students. Nonetheless, it's relatively straightforward. We have a general form, y equals x minus the left-right shift in the negative squared plus the up-down shift in the positive.